Hello friends, I am Keyur Hirpara. Today we are going to discuss how optimization problem can be solved using Excel, MS Excel. And as we all of we know that Excel is easily available tool by which we can do many things. So today I am going to explain how to solve linear programming problem and how to solve non-linear programming problem. So first of all, if you are new to the Excel and if you don't know how to create how to bring solver tool in the normal Excel sheet, so I am explaining that first. So you need to go for file, in that click on options, in add-ins and click on go, and if it is unchecked, please check it and click on OK. So in data tab you will find the solver tab. So then you can start doing your work. So to explain this problem, I have taken two different problems. One is linear programming problem, another is non-linear programming problem. So first of all, I am explaining linear programming problem using Excel solver. So as we know, here our objective function is to maximize using this function subject to these constraints. So if I use this, I need to find out value of x1 and x2 so that my z will become maximum. So let me explain this using Excel sheet. So to save the time, I created one sheet for ease of function. So to see the initial value, you can put initial value over here, any value over here. So I am putting, first of all, here we have two decision variables, x1 and x2. So initial values I am keeping 0 and 0. You can keep anything, and final also will start with the 0, and at the end you will get answers over here. Okay, then we need to type this formula of z in this cell as well as this cell. Okay, so I am typing formula equal is equal to x1, so click on this cell, minus 8 into x2, enter. So if you can see here, the formula is entered over here. Same way, we need to add all the constraints over here. So I am initial value over, obviously if I have initial value of x1 x2 0 0, so this value will be 0 only. Now I need to put value of constraints or the coefficient of constraints, all the constraints according to x1 and x2. So I am typing here in first constraint, the coordinate of the x1 is 3 and the coefficient of x2 is 2. Same way, I am just completing left hand side of the constraints. So here we have 1 and minus 1. Same way 9 and 7, 3 and 7, 2 and 5. The last two constraints are of non-negativity constraint, and that can be taken care by solver itself. So we will not bother about that right now. Now what is relation between x1 and x2, that we will put over here in this column, formula column. So I will type equal, you can see here equation, and according to that you can type formula here. x1 3 into x1, that is the final answer what we get after solution. So 3 is coefficient, C7 means final value of x1, plus coefficient into x2, enter. So this is the formula for first constraint G1. Now before that we also need to define whether we need to maximize or minimize. So here our problem statement is of maximize, so I am writing here maximize. Okay, now this is applicable to every constraint. So what I am going to do is I want to copy this formula in this column. So for that, if I drag it as it is, then what will happen, this cell also will be transferred. So I don't want that, so I am just deleting it. To avoid that, I want to freeze this C7 and D7. So for that I am just freezing it by F4. Keep cursor there and press F4 and enter. Now if you drag this formula, you will find that at each and every cell these two cells are freezed. So now no need to worry about that. Now you need to put the signs. So in first it is greater than or equal to, second less than or equal to, in these two also we have less than or equal to, and last one greater than or equal to. And on right hand side here we need to write the right hand side of the constraint. So I am keeping 6 108 70 minus 35 like this. So now we fed all the data. Now we what we need to do is we need to run this solver. So for that, click on this solver. Now you need to choose the objective function cell. So that is this. So that is Z optimum cell. So final answer will come over here. Then click here. Now you need to choose whether you need to maximize or minimize. According to that, here we have maximization problem. By changing variable means you need to enter the cells which are having variables. So here we have these two variables. Now we need to add the constraints. So to add constraint, we need to select this cell. Here different signs are there, less than or equal to, greater than or equal to, and integer, and all constraints are there. So for this particular case, we will take greater than or equal to, and in constraint you need to select limit. Click on add. Same way, second constraint, here we require less than or equal to, again this cell. Likewise you can add all the constraint. and in last we require greater than or equal to. Click OK. So you can see here all 5 constraints are mentioned over here. Now if this checkbox is unchecked, please check it, which will ensure the non-negativity condition, which is the final 2 constraint, that x1 cannot be negative and x2 cannot be negative. So this constraint can be taken care by this. Now because we know that this is linear programming problem, so you can have simplex solver, which is only used for linear programming problem. So now all data is set. You can click on solve and your problem is solved now. Now if you want to have separate answer sheet, you need to click on this and click on OK. So you can see here the final answer sheet is created over here. So this will show that this is showing that we have originally value of z is as 2 0 and final value is 2. Same way, the original value of x1 and x2 is 0 and it is end up with 2 and 0. So it is showing that if I produce or if I make 2 units of x1, it will give me maximum profit of 2 rupees. So here it is not required to produce any x2 item, and the final answers are optimum value of z is 2, x1 is 2. So if you put this x1 x2 in the equation of z, you will get final value of z. So this is linear programming problem. Sorry friends, I made one mistake over here. Instead of typing 3 here, you need to choose the cell of x1. So now you can drag this formula. Now we'll run again solver again. So solver, we already fed all the constraints and all. We have all the data set, and click on solve. Again we will generate answers, and that is answer report 2. Okay, now you can see here the value of we started with the 2 and we end up with 6, and the value of x1 is 2 and value of x2 is 0, and the final value of z is 6. So here also we need not to produce any quantity of x2, so that you will get maximum z. So if you want to change the data, see what will happen if I change one sign to plus, then you will find the difference. So I just change the sign here, and if I run solver again, and creating answer sheet again, you will get another report which shows that we started with 6 and final value of z objective function is 80. And now if I produce 10 units of x2, that will give me maximum profit. And after utilizing this much of, after producing x2, these are the values which is still left with us. So these are the resources which is still with us. So I hope all of you understood how to use solver, Excel solver for linear programming problem. In further video, I will explain